Question 10. Find the second moment of area using the table approach for this t-bar. Here's all the information you need to solve it. So I want you to pause the video here and see if you can solve this entire problem without any further prompting. Well, let's do it. Do a live one. So we've got my lower section. I will use felt pen and color. Looks like a nice dark blue. Let's go for blue. So we'll call the lower section 1, upper section 2. Okay, so the lower section has 120, a depth of 30. I'm going to get my calculator out. 120 times 30 is 3600. Where's the centroid for the lower section? It's going to be here. So it's going to be at 15. What's A times Y? That is 54000. Okie dokie, let's do the top section now. So its width is 140. 120 plus 10 plus 10. Its depth is 25. It's not so nice. The area is going to be 140 times 25. So 3,500. Its y ain't so great. 25 over 2 is 12.5 plus the 30. So 42.5. And now let's find the AY. So 42.5 times by 3,500 gives me 148,750. So we've now got the AY column done and the A column done. So we can fill in these numbers. So for the AY we're going to have 54,000 plus 148,750, all divided by 3,600 and 3,500. So plus 54,000. Okay, so the top I get, well, I'm going to do this in one go, divided by 3,600 plus 3,500. Close my brackets, put that all in there, close brackets. And I get an answer of, let's put 256 fig, 28.558. Yeah, that kind of looks about right, I guess. Centimeters. If this thing was just in the middle, 25 plus 30 divided by 2, that would be at 27. So it's slightly biased to the thicker bar, slightly above it. So 27.5, so you can see it's shifted slightly away from its average height divided by 2. Its height divided by 2, I should say. Right, so that's given me that bit. And the next bit is to find these answers. Okay, so I kind of want all of these answers there, don't I? So I'm gonna continue with my my next bit on this table, I think. So is that a good idea? Or copy and paste them? Let's transfer them. So we got 120, 30, my 30 doesn't look so hot. Three thousand and 15, 54, 0, 0, 0, 140 and 25, 3,500, 42.5, and 148, 750, and I found my neutral axis to be 28.556. Okay, so now I'm ready to do my H. So I can look back at my previous Y here. So I can go 28.556, take away 15, and do it like that, yeah? And that gives me 13.556. And I can go 28.556, take away 42.5. Ignore the minus sign, don't care about the minus sign. 13.944. Okay, so now I've got my H. Let's do my AH squared. So I've got my A. I'm going to take my H, I'm going to square it, and I'm going to find my AH squared. 3,600 times by 13.556 squared. Right, so these numbers are coming in around times 10 to the power 3, so I'm going to make them go up to 10 to the power 6 by using my eng button. Okay, so all of these are going to be times 10 to the 6 here and here. Make everything the same units, and then you can just add all numbers together at the end. So the first one will be 0.66155. Let's do this one here. So we've got 3,500 times by 13.944, square it, and let's make it into point times 10 to the 6. Use your eng button, shift it, and you're going to get a similar number, 0.68052. Now let's do the BDs. So we're going back to here. So B 120 times by 30 to the power 3 and divide it by 12. Okay, so that gives me 0.27, and this one here, so 140 times 25 to the power 3 divided by 12, and that is 0.18 229. So now I can just add up all of these numbers together. So what does that give me? So when I sum up my, so this is my BD to the power 3, I'm going to have 0.27 plus 0.18229. It was interesting to sum them up separately. So 0.45229. And then when I sum up these parallel axis theorem bits, 0.66155 plus 0.68052, that gives me a 1.34207. Add them two together, so you can see you get a lot more stiffness due to the parallel axis theorem. 0.45229, and that's going to give me 1.7944, and don't forget that's times 10 to the power 6 millimeters. Let's give my final answer in terms of meters, so that would be 10 to the power minus 6 meters. Right, so that's what you should have got. What did I get previously when I did it? Yeah, got the same result there, and seem to get the same result there. So it's looking good. Is that right? 1.75. Yep. I'm, well, slightly out. So previously when I did it, certainly same to 3 sig fig, and slight difference with my 4 sig fig. So, okay, I'm happy with that though. I think that's fair enough.